Today, I want to talk a little bit about the process module, which is likely going to make up the bulk of your simulations. Once I'm done talking about that, I'll explain why you might want to split it up into seize, delay, and release instead of just having one module for all three of them, and walk through an example with a coffee ordering process with baristas and some stuff like that. Let's go ahead and get started. So I'm hoping that you already know how Arena works a little bit in terms of create and dispose modules. The previous video in this playlist does explain that already. So what we're going to do is work on making a coffee shop. And we're going to assume that you're going to create entities and they're going to arrive with an inter-arrival time of roughly 5 minutes. So let's say that there's 5 minutes exponential time between arrivals, between customers showing up. Maybe you have two people who show up very quickly together. Maybe it takes a long time between them, but let's go ahead and run with that one. The first step in the process is going to be, that's kind of the process section there, is going to be the process module where maybe you are paying. So let's just go ahead and name this one pay. Actually, probably order before you pay. So let's bring in one here, call it order. And then the next one is going to be pay. And then after that, you're actually going to have the make coffee process. And what we're going to do is try and understand how all of these things might work together, especially if there's no room for, let's say, whip or people to stand between some of these different stations here. So opening up the order module, actually, let's go ahead and do the order module first makes sense. So if we actually look and see what kind of action we want to take, it's the default one is set to delay. In 90% of cases, especially simple simulations, you're going to be using seize, delay, release. What does this mean? Well, it means that your customer or entity will arrive, it will try and seize a resource, and that resource would be the barista in this case. Once the barista has been seized, it means that they can't help, can't really do anything else other than just work with that entity until that delay time is over, and then they're released. We'll get into a few other cases at the end, like just doing a seize and then immediately a release without any delay. But seize, delay, release, let's talk about how this works. You can actually put type, you can go into submodels, that might be a topic for a future video or future tutorial. There's also a priority. So if you have a high priority, a medium priority, and a low priority, a resource when it becomes available will attempt to serve the high priority ones first. Now every time you have a seize or release, you actually need to add a resource to this, and that's the resource which is going to be seized and is busy, and is later released and turned to idle. And for this case, let's call it a barista. And the barista is going to be seized there. I have just set it so that it's a unit of 1, so you're just seizing one barista. You could also change it so it was a set. Maybe you define a set and say barista 1, 2, 3, 4, 5 are all in the set, and you can do a few other things with that, like make sure work is spread kind of evenly if you like, or really it gets more complicated if you have multiple types of workers all within one set. Maybe you have both pastry chefs and you have baristas, and you prefer to seize the baristas, but if none are available, you can seize people from the pastry chef, for instance. Now what you can do here is you can seize more than one resource. If I attempt to seize 2 baristas, for instance, it lets me do that fine. I could also add a different type of resource. Maybe you need 1 barista and 1 manager for every ordering process. That's not the case here, so we're not going to leave it at that. We can also set a time, a delay type, because this process module does have a delay in it. We're just going to set it at constant, and we're just going to say it takes about 30 seconds on average to do the ordering process. So what this does is an entity will arrive to the system, it will go through the queue if there is one, and then it will seize 1 barista, it will delay that resource for 30 seconds, and then that resource will be released. That seems like a pretty good ordering process. The next step in the process is going to be the paying process. And we'll say that's actually pretty similar to the ordering one. So again, we'll go through and set that as seize, delay, release. Add a resource, which is the barista, and let's just say it takes 1 of those. Let's give it, maybe some people are trying to use cash, credit cards, whatever. Could be a little more complicated. Let's give it a triangular distribution, minimum of 0.5 or 30 seconds. Value most likely of 1 minute, and max we can actually make it non-symmetrical and say the maximum is 2 minutes. This means the mean is going to be a little bit higher than 1, but we don't really need to go into that at this point. Okay, so you have the ordering process and the paying process. You can do the same thing with the make coffee one. except let's say that this is a little bit more of an advanced barista case, and maybe they actually have just a machine that makes all the coffee for them. You could walk up, push a button, and then walk away, and the coffee will be made all by itself. If that's the case, you don't actually need to have the delay time in there at all. You just need to have the seize and then release, which you can't actually do here with just the process module. So what we're going to need to do is take this process module and split it apart. All you need to do is seize the resource and have someone available to go press the button, and then they're immediately released and can go help other customers. So if we can change this, we can actually remove this process module and add in from the discrete processing, or if you're in an earlier version of Arena, it could be under basic or advanced processes. What we can do is we can add in a seize and then immediately add in a release. Let's go ahead and name this is seize for machine, and we can actually add the same thing we did for the resource. We'll seize one barista. Give it a few things there. There's other settings like internal queues if you like, and a queue capacity. We're just going to ignore that one for now. Seize the machine and then release for machine. And what we can do is we can add the barista right in there. Okay, so what this does is the entity flows through. The entity gets to, and that entity is the customer, gets to the waiting for the person to seize the automatic machine, sees the worker to start the automatic machine, they're immediately released. Now that machine theoretically still needs some time, so what we can do is we can just add in a simple delay, and this delay again is to the entity, which is the customer. The baristas in this case are a resource. Delay for coffee. So we're going to just say that maybe it takes 2 minutes of delay to actually make that. That seems pretty good. That last process is set, and we'll just say they can pick it up themselves and leave when that is done. Connect it to our dispose module. That seems pretty good, but the reason I'm not connecting the first two processes together first is because I want to consider again a case that's going to be a little bit more advanced. Currently, there could actually be a big queue of people in the pay queue and a big queue of people in the ordering queue. You could have 5 people standing in line to order, 5 people standing in line to pay. Let's say we don't want that, and we want, in order for you to leave the ordering queue, there has to be someone actually available for you to help you start the paying process. What that could look like is taking these modules and splitting them apart into seize, delay, and release. So let's go ahead and do that. So we're going to do our seize for a barista. I'll just put it above here for now. Our delay for the ordering module, and then our release. And let's see, our ordering was constant time of 30 seconds. We can do that same thing for the delay, constant time of 30 seconds or half a minute. We'll call this delay for order. Okay, that seems pretty good. Let's do the same thing for the pay process. We'll have the delay, we will have the, we'll have the seize, and we will have the release. Whenever you have a seize, you have to have a release. In most cases, you have a delay too. You don't always. If the machine was, considered the end of the process of the bottom one here, I wouldn't actually need to have a delay one there. Okay, so our delay for our paying process, I think we determined we're going to do triangular, which, and actually you can do any function you want, continuous and discrete down there at the bottom. Triangular, our minimum was 30 seconds. Our mode, which again is not always the mean, is 1 minute. And our maximum was 2 minutes. Let's go ahead and set that to minutes. Great, and we will name this one delay for pay. Awesome. And let's actually name the seize and release modules too. Seize order. Maybe seize for order would be better. We'll actually add the barista in here. Good. The release, we'll call that release for the order. Add again our barista. Same thing for the release for the barista. We'll call that seize for pay. And we'll call it release pay. Awesome. Now, what I want you to think about is how we might move these modules around in order for there to be no capacity between the ordering and between the paying. So what I would do for that one is actually, I'm going to make sure that after you delay for the order, you seize the person to help you pay and then release the person that actually does, and then release the person that does the ordering. What this will ensure is that the customer arrives to the line, they order, they wait, and they're still seizing that resource. Maybe that resource is entering the order into the computer, etc. And before they can move on to the next station, that next station has to be available. It seizes the person helping them pay, releases the person helping them order, and then moves on and does that process. And that should all happen instantaneously with no time between them, is at least the assumption we're making here. Okay, let's go ahead and connect these up. Now, you also notice that I have to do a few things, so I'm actually going to have multiple baristas in this system. Let's go ahead and take the release pay, connect it to the C's for machine, and those should all flow through together. Let's actually go ahead and open up the resources tab and make sure we have a fixed capacity maybe of 4 baristas. Actually, that seems like too many. Let's just go for 3. So if we start watching this very slowly here, actually, look at that, unconnected exit point. Wonder where that is. Everything looks connected. Well, let's see if we can check the model and find it. Oh, good. I have my earlier versions of create and dispose over there. Okay, so let's actually run the simulation and let you see what's happening. So if we slow this all the way down, you can see the create module comes in, and that's again making your entities, which are papers in this case, maybe it could be people. And they go through the C's, they go through the delay, they go through the release. When there's no one being delayed in this pay module, which maybe we can make this more realistic and have all this stuff be a little bit closer, let's make the create have an entity every, let's call it every 0.75 minutes. That might be too high, it might get infinite, but we can see what happens. So as you can see, there's a few things happening. So this entity, and I wish we could see some whip right here. So there's people actually waiting in the queue to seize the order entity. They're waiting there because there's no barista available to help them order. And there's 2 people who have finished the ordering process and are waiting to help pay. So they're waiting in that seize queue, which is pretty interesting, and they haven't moved on to the order one yet. This ensures that the person helping them order is still seized. Maybe they're making small talk with them and they're helping them do that. We could actually step into this a little more closely and again watch what happens as everything keeps going. We have a lot of people piling up on the order one, a lot of people seized on the pay one, and it looks like we've got some sort of bug here because there's a lot of people arriving. So let's make sure we actually released everything, releasing one barista, releasing one barista. It looks like what we're going to have to do is change it and call them barista types instead. So seize order, we're going to call it a resource. We're going to call it, was I really seizing? Yeah, I was seizing the right resource. We're going to call it barista 1. And the seize payer, we're going to edit this one and call it barista 1. Release order, well, this was the one that should be barista 1. Barista 2 is going to help them with paying, so we're going to change the one that helps them pay to barista 2. When we release the payer, we'll call it barista 2. And when we seize the last machine, the person that does that machine, let's give it a set and say it can be either barista 1 or barista 2. Let's call it a set and call it baristas, and it would be a random order in order of what to seize. So set barista 1 or 2 random, we can delete the other one, and then when you do the release for the machine, what we need to do is we need to release a set, and it will be the set of baristas, and it will be the last member seized or the previous member seized in that set. Okay, that now means we need to have a set. So if we go into our set, we can click on and add an element. We can add barista 1, we can add barista 2. I'm no longer using just barista in general, and this one should work a whole lot better now. Okay, so what you're seeing now is that there's a lot of people waiting to seize the order. And then they go through, they finish their order. So this entity right here that just left seize pay was waiting for the ordering person, barista number 2, to be available before they could get released from the paying one. And that should help reduce whip between each of these different stations here. So if we look at something a little more closely, let's just follow one of these entities through the system. And let's say this first one is going to arrive. Let's wait till this goes up to 14. Okay, that one ended for 14, and now that entity is waiting somewhere in this queue. They're waiting in the line to seize ordering. Let's see what happens as we keep going a little bit, and hopefully we can still find entity 14 after they're through a little while. Okay, let's see, is this one entity 14 at this point? No, it's 13, so 14 right here is still waiting to in line to order. At that point, okay, now they're in the delay process for ordering and they went through that instantly because nothing else happened between then. And they're waiting at still seizing that first resource and waiting to seize the person helping them pay. As soon as that person helping them pay is available, they're going to start working with this person, which they just did. And now that entity 14 is somewhere in this process, they're in the delay process right now to actually pay. They just got released, they show up to the machine, and they have to wait right now, even though the machine's automatic. No one's available to start it. Barista 1 is still busy, Barista 2 is still busy, and they can't actually do anything. And as soon as one of those is available, they should hopefully go press that button, start the machine, and let that person finish. So that should give you an idea of why you might split up seize, delay, and release into different modules, which can be a little more complicated, but can be a little bit more reflective of real-world systems. So I think you saw if you're doing something like that, you have to make sure it's split to specific entities. I also did show you how to do a set in that very last process. There are a few other cases in which you might be able to use seize, delay, release and use process modules, so I'll show you a few different examples. This first one is a Kanban example. I talked a little bit about this in the create and dispose settings. You can just basically represent a machine with a Kanban process or a machine with a delay module. So this first process is called machine 1. It seizes resource 1 and does a seize, delay, release between 2 and 3 minutes. Machine 2 is very, very similar. This seizes resource number 2, just one of those, and this is an exponential time of 3.5 minutes. And then the very last process here in machine 3, very, very similar, except this one is now triangular with the value shown here, most likely value of 2. And again, you can do non-symmetrical if you would like for these process modules. So those are 3 simple seize, delay, release processes that you're using here. We can also look at something much more complicated. This example is going to be one I'll use a little bit going forward too, and this was also used in the process or the delay and create module, or the create and the dispose module videos. You can see right here, and again, this looks a little bit different because this was made using a earlier version of Arena. We have a seize operator 1. This is a seize process right here. It goes through, does a delay, and before you can release it, you have to make sure before you can release 1 right here, you have to seize operator 2. That's very similar to what you saw. So before it can leave machine 1, you have to seize machine 2. Again, very similar to that. There's a few other things, and this module does end up getting pretty complicated. There's a bunch of stuff you can do, like pre-standard seize, delay, releases, but you can also change it to be sets. One thing I do want to highlight is random workers. So if you are, for instance, wanting to seize 2 random workers to help you do something, you need to make sure you seize 1 random and then seize 1 worker, a second random worker. If you don't do that, what you'll try and do is, let's say you have worker 1, 2, 3, 4, 5, 6. If you try and seize 2 random workers, and if you add the syntax somewhat like this, you seize 2 workers from the set, it's actually going to try and seize like 2 of worker 4. If worker 4 is the one it picks, you want to seize 1 random one and then another random one, just to show you some things that are possible with that one. So that's all the time I have for today. I hope this video was helpful and did help you understand the process module, as well as some more advanced things of splitting it up into seize, delay, and release. Remember, whenever you have a seize, you need a release, and you generally should have a delay or some other sort of setting in there too. Hope to see you checking out future videos. Remember, you can subscribe to see more of these. With that said, see you next time.